Hello and welcome to the C++ Insights YouTube channel. I'm Andreas Fertig. I work as a C++ trainer offering classes worldwide, on-site or remote. This is my YouTube channel where I use my tool C++ Insights to teach you various topics related to C++. Welcome back to another C++ Insights episode. Today I like to teach you a bit C++20, especially concepts here and where and how they can be really convenient. The example I already typed is a very thin implementation of a pseudo optional. All we have is a class template optional and a copy or conversion constructor, right? It doesn't have any data members for the moment, and we are not going to add them in this episode. What I'm trying to show you here is more that you're implementing a wrapper around a type like a pseudo optional, right? You can reach for optional if you really need it in the standard library, but sometimes you need custom modifications, custom implementations, or you approach this pattern in a different scenario. This is our base. We have the class optional. What it's supposed to do, and I focus only on the copy operations, more precisely only on the copy constructor today, is it should mimic all the special member operations that the type it wraps has. So in my case, T. What does that mean? Well, if T is copy constructible, then the pseudo optional from T should be as well. And if not, it shouldn't. And the same is true for move operations and the destructor. But as I said, to simplify things, only copy constructor today. Yet line number 7, what does this actually do? Is this the copy constructor? No. Line number 7 here, this is a conversion or converting constructor because it takes a T and not an optional. I made another episode that teaches you that you can never make a copy constructor a template, and this is true for today's lesson as well. So what I have now is I have a data type not copyable. It contains an int value and it comes with a constructor here, and the copy constructor, as you can see, is deleted. And now I have two test cases. One says test OK. I'm creating an optional of int, calling that one alpha, assigning the number 5 to it, and then I copy construct another optional of int beta and I assign alpha to it. As you can see, my code compiles, so I'm fine with that. And then we have should not be copyable. So I have an optional wrapping in not copyable. I initialize an optional object apple here with not copyable of 5. And I have another optional of not copyable orange, and that gets initialized with orange. And it compiles, right? And this is not good because my wrapper here now behaves differently than my not copyable. What can you do about it? Well, you can write tons and tons of code if you happen to be an STL implementer trying to implement pseudo optional. This is why I downgraded it to just the copy constructor or the conversion constructor here. Like this content? Your company can hire me to teach a C++ class with even more details answering your questions. Feel free to reach out. What you would do pre-C++20 is something like the following. We create a new class, optional copybase. We make that one a template. Say it takes a type name T and a defaulted parameter that checks whether your T is copy constructible. If that's the case, we simply create an empty struct optional copy base here. And as you all know, right, a empty struct is copyable. So that would be for the case when it is indeed copyable T. And then we create a specialization optional copy base for T and specialize the second parameter to false, and that one here provides a default constructor, otherwise it would not be default constructible, but you have to check whether the type should be default constructible. And we default the move operation here. You can also go for deleting the copy operation, but then you would have to bring the move operations back. So that one would be the simple version for now. It saves me one line of writing. If you look at the big picture, then you know that I just said it. The moment I'm tampering with the move operations, we have to take care of the other stuff. So you could have technically a class where it wraps something that's not copy constructible but copy assignable. Anyway, I have my optional copy base now, and I say that my optional inherits privately from optional copy base of t. The rest here is unchanged, so it's more or less just deciding from which base class you inherit to disable or enable the specific member functions the type T comes with. My not copyable here is unchanged, my test OK still runs, I expect that one, and my should not be copyable, you can see the crucial line here is in a comment, and if I remove that one, you can see yes. This is the compile error I was looking for. Well, not really, because it's somewhat hard to read potentially, but we can see here that optional copy base here triggers give that thing a better name, and it might be even easier for users to figure out that they are just trying to copy construct something that's not copy constructible. As I said, so this is the C++ 17 version, right? Imagine now you have to do this for all the cases. So for the destructor, for the copy constructor, for the copy assignment operator, for the move constructor, for the move assignment operator. That's a lot of boilerplate code to write and then inherit in the correct order just to get this behavior. This is where concepts in C++20 I think really excel. So here is a concept-driven implementation in C++20. Can see here no code in lines number 2 and 3. What I had earlier is just gone. I have my optional, and my optional doesn't need to inherit from anything. It's just the plain type as we would write it. So you can see here, this is my regular constructor here. That one is constrained by a training requires clause that says only make that available if the wrapping T here is copy constructible, trivially copy constructible. Then default it. Otherwise, it's not there. So the same scenario as before. My test OK here runs fine with 2 integers. My not copyable is in a comment. Once I enable it, we can see here, yeah, that one also fails. And this time we get the error message that it's not trivially copyable, or the requirement for trivially copyable fails. This is a way to do this. This is a way to implement this with C++20's concepts. And the beauty about that is the error message gets a bit nicer, but it requires you way less code to write for the implementation here. And that means it's easier to understand, easier to follow, and easier to maintain a lot of code, and you have to maintain that. Having less code is a point I cannot stress enough. It always helps you. You are so much faster if you reach the goal with less code than with more. Think about that, and I hope that C++20's concepts enable you as well to write less code and more robust code in the future. That's it for today. Thanks for watching.